All right, so we're going to find some rules here. So in question A1, what's another way of saying 2 to the third times 2 to the second? I'll take a volunteer. Nolan. So how many 2's are we multiplying together? 5 2. So 2 to the third times 2 to the second is 2 to the fifth. All right, and so here's 2 to the third, here's 2 to the second. Clearly we're multiplying 5 2's together. So what did we do with the exponents? What did we do with 3 and 2 to get 5? We added them up. So if I have a to the m times a to the n, and we can take another volunteer here, what rule will we have? A to the m times a to the n is equal to? Kaylee. So who do we have again?
Macy, Allie, Miles.
Miles.
It would be a to the power of m plus n.
All right. And this is a rule that we've been working with for the last couple weeks. Okay. Well, we're going to use this rule to find a new rule. All right. So what's another way of writing 3 to the fifth is equal to 3 to the third times 3 to the second? A volunteer? What's another way of writing this out?
Allie.
Allie?
We had 3 to the fifth divided by 3 to the second
Is equal to?
3 to the third.
3 to the third. Okay. What did you do with 5 and 2 to get 3?
Subtracted them.
You subtracted them. So if I have a to the m divided by a to the n, I'm subtracting the exponents because the bases are the same. So what is a to the m divided by a to the n? A to the m minus n. All right. Our next rule. So what's another way of writing 2 to the third times 2 to the, or 5 to the third? 2 to the third times 5 to the third. Miss Hunnison.
Wait, an expanded form?
Sure. Or any form you want to give it to us.
10 to the third?
Oh, so this is equal to 10 to the third. Because I have 3 groups of 2, I have 5 groups of, or 3 groups of 5. So that means 2 times 5 is 10. So I have 3 groups of 10 times 10 times 10. All right. Okay, great. So what did I do? So for the rule, what am I going to do if I have a to the m times b to the m? So the bases are different, but the exponents are the same.
Kenny Brown, Buddy Rydell, Macy.
Claudia.
A B to the n power.
ab to the m power. So is a and m being taken to the n power or just b?
A and M.
Okay, so in that case we need to put this in parentheses because otherwise we do the exponent before we do multiplication. All right, for question D, well, this is a rule that we've seen an awful lot of. So what will I do with the exponents if I am taking a monomial to a power?
Macy.
Macy.
It'll be, wait, for, D3?
Yes, D3.
Oh, actually, I didn't really get that one.
Well, hold on a second, Macy. If I have 5 to the third power, that will be equal to 5 to the which power?
9?
Ninth. What did you do with 3 and 3 to get 9?
Multiply them.
You multiplied them, okay. So what is a to the m to the nth power?
N.
Yeah.
A to the N.
Because we're multiplying a and m together. All right. For the last one, we're gonna do this one as a group. So please unmute yourself so that you can shout out answers. What is 2 to the third power in standard notation? This is no trick. Nolan? 2 times 2 times 2. That's expanded notation. I want standard notation. What is 2 times 2 times 2? You can shout out if you want. 8. What is 2 squared?
4.
4. What is 2 to the first?
2.
What did I do with 8 to get to 4?
Divided it by 2.
I divided by 2. What did I do with 4 to get 2?
Divided by 2.
Okay, so if I go 2 to the 0 power, what am I going to do with 2 to get the result here?
Divided by 2 and get 1.
And I will get 1. So actually, any number, doesn't matter what number it is, any number to the 0 power is always going to be 1. Always going to be 1. So 50 billion to the 0 power is 1. It's always 1. Anything to the 0 power is 1. Let's try this. How about Ray? What is Ray to the 0 power? Anything to, it's 1. Because anything to the 0 power is 1. So Ray, you're number 1. All right, so well, let's keep going. If I have 2 to the negative first, because I'm just following the pattern, what will I do with 1 to get the next number?
Divide by 2.
Divide by 2. 1 divided by 2 is 1/2. Well, 1/2 is just 1 over 2 to the first power, isn't it? How about 2 to the negative second?
1/4.
It's 1/4. And 1/4 can be written as 1 over 2 squared. Oh. What about 2 to the negative third?
1/8.
It's 1/8, and 8 can be written as 2 to the third, right?
Yes.
Notice how every time we have a negative exponent, we do not get a negative number. We get a fraction, don't we? So negative exponents give us fractions. So, and also notice, look, once we take our base with the negative exponent, turn it into a fraction, what happens to the exponent?
It turns to positive.
It turns to positive. So our rule, if we have a to the negative m, that will equal 1 over what?
Two to the m. Oh wait, a to the m.
A to the positive m power. There you go. And so that's your 6th rule. I highly recommend you write all 6 rules on the outside of your folder so that they're in an easy reference place so that you can do your homework a little more efficiently. These rules will have to be memorized. There's no other way about it. You've just got to memorize them just like you memorized your multiplication facts. It is expected when you go into high school that you already know and can use all 6 rules. And all 6 rules can be combined into one problem like we've been doing in the past. So you have to be able to not only know the rules, but apply them in different situations. Are there any last questions on what we've done today?